Hey, welcome. In this video, we will solve problem longest increasing subsequence asked by companies like Amazon, Microsoft, Facebook, Google, and many others. Now let's solve this problem longest increasing subsequence. Okay, again one of the most important problem on DP. Okay, and this is a one pattern that we have already solved. Subsequences again similar to that problem, subsequences problem. Okay, so now let's check out. So here given an integer array nums, so this is my nums array, return the length of the longest strictly increasing subsequence, right? It should be strictly increasing, right? So what is the longest subsequence here? Longest strictly increasing subsequence. So I will take, if I am starting from 2, right? Then I will take 3 greater, then I will take 7, or either I can take 101 or 18, right? Both are greater. So the answer will be 2, 3, 7 or 18, right? Or 101, but the length will be 4, right? So this is the longest, right? If you can try any other possibility, you won't get the maximum or the maximum length here than 4, right? Here, if I start from suppose 0 and I am starting from this 0 or this 0, right? So if I'm taking 0, 1 and 2 and 3, so I'm getting here 4, right? So that means I should start from the first 0. So 0, 1, 2 and 3, and I am getting here, this is my longest strictly increasing subsequence, right? So longest subsequence. Okay, now let's see, right? We understood the problem statement, right? Basically how, what we need to find. Okay, now let's figure out how we can find this. Okay, so basically we have given this nums. So I have nums, basically this 10, 9, then 2, 5, 3, 7, 1, 0, 1 and 18, right? This is my nums, right? And if I simply put the indexes of my array, this will be 3, 4, 5, 6, 7. So that means I have an array of size 8. Okay, so let's see how we can solve this problem, right? So if I talk about the first approach that come to your mind, that is basically you will try all the possibilities, right? You will generate all the possible subsequences, right? So what you will do, you will generate all possible subsequences, right? One approach. If I'm generating all possible subsequences, basically how I will generate 10, 9 and so on, right? Like then I will simply, I can miss 9, then I can say 10 to 5, and then I will simply basically store it. So next step will be the first generating all, then I will store into some of an array or DP. So I will store it, right? Or I will store it in a string, right? Or like suppose an array elements, right? Like in a string. So suppose if I am storing in an array, right? Then what I will do, I will simply calculate the length and I will compare, right? And I will get the maximum, right? So that is one possible way, right? That's a brute force one, because we are not taking care of increasing here strictly. We are not being choosy here. We are generating all possible substances. That is what brute force is. You are taking all the possible scenarios. You are not doing going greedy. You are not choosing anything, right? Generating all possible answer, all things, and you are definitely, that's why in brute force we will definitely get an answer. That's a surety that we will definitely get the answer, right? But it will take time. And how it will take time, basically you will, on each on each number, right, you will have two possibilities. Either you can pick it, right, or you not pick it, right? So on each number you will do for 10, then similarly you will go for 9, then you go for 2, 5. So basically how you will do, so you will start suppose by an empty, right? So you have an empty element, that means you have not. So then you have a choice, either you can take 10 or you can simply go ahead without taking 10. Then you have a choice of 9. You can take 9 or you are not taking 9. So you are with 10 only. If you are taking 9 here, you are creating one 9, and if you are not taking, then you are empty. And again, you're starting with 10, 9, and you have choice of 2. If you are taking 2, it will be 10, 9, 2. If you are not taking, it will be 10, 9 only. Similarly, here, if you are taking 2, it will be 10, 2. Not taking, it will be 10 only. Similarly, here, it will be 9, 2, and not taking, it will be 9 only. So similarly, here you can see 2, here you can see 4, here you can see it will be 8, right? So it will be 2, 4, 8, and it will be 60, 32, right? So that's a series of GP if I submit the all the possible iterations, right? So GP series a power r minus n, r power n minus 1 upon r minus 1. What is r? That is 4 by 2. That is r. That is 1, 2 basically. And if I put it here, so a is 2, 2 power n minus 1 upon 2 minus 1. That's time complexity will be 2 power n. So here we are getting a time complexity of 2 power n. That's very high. That's very, very high. Take this, suppose if your n is 10 only, right? So 2 power 10, that means 1024 iterations you will do, right? Nearly approx 1024 iterations, right? So that's very, very high. Okay, we need to reduce this time complexity. So we need to find out, we need to bit choosy during generating all cases, right? So let me copy this nums and let's start some smarter approach, right? So basically what I need to do, I need to find strictly increasing subsequence, right? Increasing subsequence, that means it should be increasing, right? It should be increasing. That means it should be greater from the previous, right? I say from the previous or the last term, the last item you have picked. Suppose you have choose the last item, suppose 9, and you are going to choose the next item. So the next item should be greater than 9, right? Your next item should be greater than 9. Okay, so basically what I will do, right? I want two things, right? I am chasing taking next item, right? Next item, and I am taking one previous, right? So my next item should be greater than previous. So I will take, if my next item is greater than previous, so I will take it. I will take it, right? So I want to play between these two variables, next and previous, right? So I will create one function where I will have basically nums, and I will have one next, and I will have one previous, right? So what I will do, right now, let's see if I'm starting from this, right? Can I take this? Can I take this 10? Yes. So for this, what is my previous, right? So I have not defined. So let's see, for this, my previous will be minus 1. Okay. Because I'm starting, right? There is no previous. So for my previous will be minus 1. That means I can take this element, right? I can take this element. So what I will do, I will simply start that I will take a call of 0 index. Can I take it? Can I take 0 and the previous is minus 1? So yes, you can take it. So I will take it and I will say that I will return because I'm taking it. So I am picking it, right? I am picking 10. So I will update the count with plus, right? I will basically do 1 plus and I will choose the next element, right? I will choose the first, I will take it and I will move ahead, right? So I will be at 1 and the previous will change, right? So the pre my next pointer, like here the next pointer was 0, will make it previous, so it will make previous, right? So basically what this means, right, when I'm writing that I have one next and I have one previous. So basically, suppose if I am writing f7 comma 7 comma index, basically I'm writing indexes here, right? So I'm writing indexes here. So suppose you have f5 comma 2, right? So that means basically you are at 5, you are at 5 index, right? And whose previous is 2, whose previous is 2. So for 7, the previous is 2, right? You have taken like this. You are at 7, you are choosing 7, you are taking a count of 7, whose previous is 2. If I am writing f, mm, suppose this 0 comma minus 1, that means you are taking zeroth, right? Whose previous is nothing, right? Which has no previous, right? So basically, if I say I am writing 5 comma 2, so you are selecting from fifth index whose previous is second index, right? Here you are selecting from zeroth index whose previous is, who has no previous, right? Basically, which has, you can say which has no previous, no previous, right? So it will also it will also count as like from 0 to 5th index, which has no previous, which previous is second index, right? So basically, I can take a call of it, right? I can take a call of it, and then I can simply update with count. So basically, it will give me the length. This function, right? This function will give me the length. So that is the length that is starting from 5th index whose previous is second index. That is the length that is starting from 0th index whose previous is like which have no previous, right? So basically I will call this function, and let's suppose, so I have one pointer f with one next pointer. Basically I'm checking the next, and right, and I have previous, right? So basically what we basically do, right, we pick it or not pick it, okay, pick call and not pick call, right? So basically, eh, if you can see in generating, yeah, we are taking it and we are not taking it, we are moving ahead. And how we basically move, we move with the indexes, right? This index, then we move to the next index, then next index. So what I will do, I will say instead of next pointer, let's say index, because we will move with the indexes, right? So we will move with the indexes, right? I will be choosy, I will be choosy for that index and I will move ahead. I will be choosy for next that index and I will move ahead. So this is my function, index and previous, right? So see, if I am not taking it, if I'm not taking, what I will do, I will simply move ahead. So can I say I will simply move ahead? So I will be 0 plus f index plus 1, and my previous will be same because I am moving ahead, right? So see, you were, when you are calling 10, that means you are selecting 0 and a minus. So you are selecting 0th index, you are starting from 0th index which has no previous, right? But suppose if you are not selecting it, you will move ahead, you will simply 1 and you will select 9. That means you are starting with 9, that is no previous, right? Suppose also not picked 9, you are not taking 9 and you are again moving, so that means you are at index 2 which has no previous. You are starting from no, starting from 2, you are starting a complete new journey, right? So whenever you are starting from 2, whenever you are starting from 9, you don't have any length. That's the first element basically. So you don't have any length, you will say 0 plus f of index plus 1. Okay, now, now see, when I will select the element, when I will take 10. So when the previous is minus 1, can I take 10? Sure, like you will say, go ahead, I can take 10, right? But now after 10, can I take 9, right? So once I have taken it, I have said, yes, I will take 1. Basically, I will update the length because I'm taking it. I will say 1 plus and I will call the next function. I will check the next. Can I take it 1 comma 0? Can I take this one 1 and previous, like here my previous will change to the index 1 0. Can I take this? You will say no, right? Because if I'm taking 9, that's a decreasing. That's a decreasing. So here I won't take it. I will say move ahead, right? You will say move ahead. So I will move ahead 2 and with the same previous. So 2 comma 0. What is 2 comma 0 representing? That I am at indexing 2, right? Whose previous is 10. 10. I am at 2 whose previous is 10, right? Now, can you take a call? Can you take it 2? Can you take it 2? Right? So if you here you are not taking it, it will be 0. And you take it 2. No, we can't take it. Again, you won't take it and you will say, let's move ahead. So you will move ahead with previous 0 only. So can you take it 5? No, you can't take it 5 and similarly, you will move ahead. You won't take it, right? But if you are taking it, you will say 1 plus f of 1 0, right? Basically, you will say 1 plus, you will update the length. So this is my not take case, or let me mention it here, that is I am not taking it, right? And my take case will be basically 1 plus f of, and I will move ahead, so index plus 1, right? And my previous will change to this index, right? So my previous will change to this index. Now see, when I will take this call, when I will take it, right? When I will take it basically. So we need to figure out that when we will take this call, when I will take it. So I will say that if I am taking this, there will be some condition. Whenever like my previous is -1, I am very easy, I can take it. No need, no nothing to ask. So whenever, if condition, if my previous, if my previous is equals to -1, I can definitely take it. No worries. Now, if suppose your next basically I started with next, if your next element is greater than your previous, you can take it, right? So I can say if my nums, basically here we have taken nums, so if my nums of index, right, if my nums of index is greater than, so if nums of index is greater than your nums of previous that you have select previous, what you will do, you can take it, you can have a take call. So basically this is one case where you are finding, so suppose this is you are finding maximum, or you can take any variable. So let's suppose I am taking length here, right? And my length, the final length will be math dot max, basically I will find the maximum. So see here, right, this is my length, 0 plus f of index plus 1 previous, not take call. This is my take call, right? Right. So these, there will be two function calls, right? One if I'm not taking it, one if I'm taking it. But taking has a condition that your previous equals to -1 or your nums of index should be greater than your previous, right? If it is this, then you will take it and you will move ahead. You will say index plus 1, right? When you are moving ahead, index plus 1 and your previous will become the index, right? So your previous will change with the index. That's a take call. Now what you will do, you basically your length will be method dot max of these two, right? So what is this? Length, right? And what is this? Basically your take, right? So your length will be method dot max of length and take, right? And you will return it, right? You will return it. When I need to stop, right? What is the base condition? So see, when I'm moving ahead, when I'm moving ahead here, right? I will reach to end. Suppose my index is pointing to 8. That means I have reached to end. So will I add this element? No, I won't add this element, right? So if I'm not adding this element, right, I can return 0. Yes, whenever I will simply reach to the end, whenever my index is reached to the end, I will say return 0 because there is nothing to add. We are already adding it plus here. So I will simply return 0 here. And yeah, that will be my base case. So my function will start from here and it will go till here, right? So what will be the time complexity here, right? If I am simply saying what will the time complexity, so again time complexity, there will be different function callings again and again. So again we need to decrease the time complexity. So see, that's 100% chance that when you are solving these problems, right, you will get the same function call again and again. You will get the same function call again and again. Let's understand this example by one binary search tree, like binary tree. So you will get it, right? So we will basically make a tree diagram of it. So let's take one case so that we can quickly make it. So suppose I have 2 comma 1 comma 0 comma 3. This is my, okay, this is my array, right? 2 1 0 and 3. Okay, and now let's start. So what I have a function call with the index and the previous. Okay, so what are these indexes? 0 1 2 and 3, right? So I will do a function call. My first function call will be 0. I am betting on the 0. Should I take it or not take it? I have -1, right? So I have this, previous is nothing, previous is -1. So that means I have a liberty, I can take it, right? So if I am taking this, what I will do, I will update the length 1 plus, I will increase the length, right? And I will take next function call, I will at 1. And when I will at 1, right, my previous will change to 0. Remember, my index will be index plus 1 and my previous will change to the index. You can see here, my previous is changed to the index and I am at index plus 1, right? So I am at index plus 1. Now, will you take 1? You have started from 2. Will you take 1? No, you won't take it. So this call won't happen. You will do this call. Basically, do the right call. Okay. And in right call, basically you will move ahead and you won't take it. So you won't take it. You will move ahead. You will have 2. You will at 2 with the last value at 0. Basically, the last value will be at 2. Right. Now, will you take 0? Will you take 0? So no, again, you won't take this call and you will move ahead and you will at 3 with the last value will be at 0. So you were at 3 with the last value again 0, that is 2. Now, can you take 3? Basically, you have choose 0. That means you have selected 2 and you are counting for 3. Yes, you can take it. So basically what you will do, you have a one function call, you will do take it and you will move ahead and your index will become, your previous will become the index, right? So now you have 4 comma 3 call and here basically your index is reached to the n because here n was 4 and you are at 4. So basically it will return 0. Basically you can see it will return 0. So it will return 0. This will be 1 plus 0, right? So I will return here basically 1 because this called it. So I will return 1, right? And here also you have this choice. Suppose if you are not taking it, right? So you are not taking it. So basically again that's a take call. But if you are not taking it, so it will be 0 plus f of 4 comma 3 again, right? Not 4 comma 3. If you are not taking it, that means you are at 4 with 0, right? Because you are not taking 3 as well, right? Now this will also, this will return 0, right? So here you have 0, here you have 1, which is maximum, 1 and 0, 1. So you will return 1 to it. You will return 1 to it. Now you have not taken this one, so this will be 0 plus 1, and here we are not taking any value, so that is also 0. So here the maximum value I am getting 1, so I will return 1 to it. This was also 0 plus this function, so this is also 1, it will return 1 to it. And here we have 1 plus 1, so here I will return 1, but again we have these function calls as well, right? So now when I'm reached to here, right, I will do, suppose if I am starting from one index, right? So I will start from one index, that means 1. So I will say if I am starting from this means 1, that means I am not taking 2, that means I am putting 0 here, the length. So what I will do, I will come to 1, right, and my index will be 0, right? That means I am starting from 1. Now I have a call, right? This function call, basically, can I take 1? Yes, because if I'm not taking it, it will be, if I'm not taking it, it will be -1. If I'm not taking it, it will be -1. Now I'm saying, can I take 1? Can I take 1? Yes, whenever you have previous, you can take, right? Because that means you are doing a fresh starting, so you can take it. So if you are taking it, you have a 1 plus f of next function call, that is 2, and your index will become previous. Basically, your previous become index, right? So 2 comma 1. So here, what is the index 2? I am checking for 0. Can I take 0? Can I take 0? So is 0 is increasing? Also 0 is also not increasing, right? So I won't take it. I won't take it. This one function call, I will say 0 plus f of, and if I'm not taking, I will simply move ahead and my previous will be still 1, right? No, I have at 3. Can I take 3? Yes, 3 is greater than 1, so yes, I can take it. I will say 1 plus f of 4 comma 3. If suppose if I'm not taking it, it will be 0 f of 4 comma 1, right? So if I am at 4, right, basically what it will return, it will return 0. 0 plus 0, it will be 0, and 4 comma 3, it will also return 0. So 1 plus 0 will become 1. So here I have 1, here I have 0. Here I have 1 plus 0, here I have 0, it will return 1 to it. 0 plus 1, it will return 1 to it. Okay, and we have 1 plus 1, 2, it will return 2 to it, and this is 2. So what is the length we get here from here? This is also 2. 1 plus 1, this will also 2. So here we got 2 1, right? One solution, that is we are getting 2 1, and here we are getting 1 and 3, right? Similarly, if I do the next call, right, I have started with taking a count of 0, right? If I'm not taking it, I am starting with 1 comma minus 1. Suppose even if I am not taking this one as well, right? If I'm not taking this one as well, so it will be 2 comma minus 1. So can you start from 0? Yes, I can always start. Again this function call, again this function call, right? So if I move ahead, right, and it will say, can you take 2? Yes, I will take 2, and it will be 3 comma 2, right? So now I am thinking about 3. So yes, I can take it. I will simply put 1. 1 plus 1, again it will return 2, right? This will also give 1 as an answer, right? And basically this is how it will simply give the result. I'm not making a complete tree, but that's a partial binary tree, but basically how this is how my function is working, right? So basically this is how you can understand when my index is reaching to n, I am returning 0. When there is a not take call, I am simply adding 0 plus index plus 1 and previous. When previous is equals to minus 1, I can take it when what are the conditions can I take a call? So you can see whenever my previous is minus 1, I can take it. This is a take call. Whenever my previous is minus 1, right, I am doing a take call. Minus 1, I am doing a take call. And whenever my index num is greater than the previous. So here you can see whenever my index 3 is greater than the previous. So when 3 is greater than 0, 3 element 3 greater than 2. Yes, so 3 is greater than 2. I am taking a call, right? Here 3 is greater than 1. 3 is greater than 1. I am taking a call, right? So in all these conditions, I am take this call. Basically, this is how you can solve this problem. Now what you need to do, like here when I'm solving this, there will be multiple sub problems, like here 1 comma minus 1, 2 comma 1, right? Here 2 comma minus 1. Here we have a bit of unique, but when you come do a complete binary tree, you will have similar sub problems, basically similar function calls, right? This function call maybe happen here, this same function call will happen here. So when we are storing the maximum length, we will store in our DP, we will use computation, basically memoization, we will use DP, and we will store the maximum length. So how we will use DP here? So basically, what are the things we have? So if I move ahead, right, what are the things basically in my function? My function is calling with the index, and my function is calling with some previous item, right? So f of function index and previous. So what I will do, my DP will have index and my previous, right? So basically how you are starting, your index is starting from 0 and it is going till 4, and 4 we don't need to store, right? So it will start from 0 till n, and my index length will be from 0. Basically my index pointer can be 0 to n. Similarly my previous pointer should be 0 to n, but my previous is starting from -1 and it is going till n minus 1. So it is starting from -1, right, and it is going till n minus 1. Okay, so what we can do, if how can I store -1, and if even if I'm storing it, how it will tell. See, this is a 2D array. This is a 2D array. Suppose if even if this is an array, right, you can define array of 0, you can define array of 1, but you can't define array of -1, right? So if you are putting previous with -1 value, it will say undefined, right? In JavaScript it will say undefined, so you need to make it defined. So basically previous -1 is indicating that this is an initialization, right? Initialization. So you can simply replace -1 with 0, you can replace 0 with 1, you can replace 1 with a 2, and so on. So similarly you will replace n plus 1 with n, right? So basically here your this will also be of n, this will also be of n, so your dp size will also be n square, right? Because it will store for all the function calls, all the function calls possible, different combinations possible. So what you will do here, basically you will store this in your dp, right? So suppose this is your length, right, and I was returning length, right, I was returning length after this if condition. So this was if condition here, and here I have not written, but I was returning length. But instead of returning length, what we will do, we will do one step of dp. So I will say my dp of index previous, right, is equals to length, and I will simply return length. But here also I will mention the dp case, right? So what I will do, before first of all mentioning in the day case, I need to change it. I need to change my previous. What I will do, I will change previous. How? So my previous will be previous plus 1, right? Or you can say previous index I will mention, right? Let's take one previous index equals to previous plus 1, right? And what I will do, I will simply say if dp of index comma previous index, if it is not equals to -1, we will simply first create a dp with -1. If not, then I will simply return dp of index comma previous index, right? And here also it will be previous index, and we will create dp, basically a 2D dp of basically taking new array, right, of size n dot fill with 0, and I will map it, right. It will basically I will create a 2D array, new array. Basically that's a syntax of creating 2D array, n plus 1, and I will fill with -1, right? So this will be my approach to solve this problem, right? And if you solve this problem, because if now you are using dp, so what will be the time complexity here will be big O of n square, because your index will go reach to the end, your previous will also reach to the end, right? So it will be big of n square. And what will be the space complexity? So for dp, for only dp, it will be big of n square, right? And for your stack memory, right, it will be big O of n, because the basically the height of your binary tree, right? So that will be time complexity and space complexity of this approach. In the next video I will give you the code implementation of this problem, and then we will do a bit of dry run to understand how this code is. Okay, so see you in the next video.